Hello everybody and welcome to video number 2. In the previous one, we decided to start learning a programming language with a roadmap that observes the coding world from above, so we can pick up our path intelligently. I talked about some basic parts of a computer as a first step of our plan. I also mentioned some topics like memory addresses, CPU instruction set, machine code, and abstraction. Today I'm gonna explain more about these topics and find out how programming languages connect our brains and CPUs in a logical way. In computing, a memory address is a reference to a specific memory location used by software and hardware. RAM is made up of a collection of memory addresses which can be used to store bits of data. In older languages like C, programmers are able to work directly with memory addresses using a feature called pointers. But this is not very common in modern languages. Computers rely on a CPU, and a CPU can understand a specific set of instructions in the form of ones and zeros. Machine code is a computer program written in machine language. It uses the instruction set of a particular CPU architecture. You know what? Machine code is the lowest level of software. All programming languages are translated into machine code which CPU can understand, so the computer can execute them. Most programming languages include a program called a compiler or an interpreter which performs these translation steps. Depending on the language you choose, your code is either interpreted or compiled into machine code. Just to give a few examples, JavaScript and Python are interpreted languages, while Java is a compiled language. Compiled languages are converted directly into machine code. As a result, they tend to be faster to execute than interpreted languages. They also give the developer more control over hardware aspects like memory management and CPU usage. In an interpreted language, the source code is not directly translated by the target machine. Instead, a different program, aka interpreter, reads and executes the code line by line. Interpreted languages tend to be more flexible and often offer features like dynamic typing and smaller program size. Also, because interpreters execute the source code themselves, the code itself is platform independent. It means they are not dependent on the type of CPU or operating system we are working on. Operating systems like Microsoft Windows, Linux, Apple macOS, iOS, and Android. Abstraction is the ability to work with higher level tools that simplify the required scope of our understanding and skills. It's a very generic concept that's not limited to programming. You can find it everywhere in the real world. In computer science, a high-level programming language is a programming language with strong abstraction from the details of the computer hardware. Higher-level programming languages are more programmer-friendly and closer to natural language, whether they are compiled or interpreted or the combination of two. Their syntax rules, keywords, and statements are more human readable, like JavaScript, Python, and Java. They are pretty well structured and easy to debug, whereas low-level languages like assembly are difficult to debug and you need to have high level of hardware understanding. They are machine friendly and they're totally machine dependent. Okay, Whatever type of programming you're into, you'll run into situations where you need to know how computers interact with each other. This typically occurs over the internet. Internet is nothing more than a global collection of connected computers. In other words, it's a global network. Each computer in the network agrees on a set of rules that enable them to talk to each other. To a computer, talking means transferring data. As we discussed before, all types of data like images, videos, and emails can be represented as ones and zeros. Therefore, you can think of internet as a very large set of computers that can transfer ones and zeros amongst themselves and protect the meaning of that data. Most human conversations require at least two participants. In most cases, one person initiates the conversation and the other responds, assuming they are both present and available. Internet is a digital conversation medium. The computer initiating the conversation is called the client, and the computer which is responding or answering is called the server. For example, let's say you open a web browser and go to www.google.com. In this scenario, your web browser is the client. By extension, you can also think of the computer you are working on as the client. In a more abstract sense, you are the client because you are the one initiating the conversation by typing google.com and hitting enter. And your browser is requesting to start a conversation with one of Google's computers. Google's computer is called the server. It responds by sending the data required to display Google's web page in your browser. And Google's web page appears in front of your eyes. All internet data transfers utilize this sort of client-server relationship. In the next video, I'll walk you through the command line to test and troubleshoot your internet connection. We'll also practice some other commands that will give you a feel for working on the command line. It'll be faster and more efficient than scrolling across graphical interface. Hope you enjoyed the video, guys! Please don't forget to leave a like and subscribe the channel so you don't miss new videos. If you have any question, please make sure to comment below and I'll try to answer it as soon as possible. Thank you so much for watching. I'll see you soon.